This is our Unit 8, Day 5 video. And what we're talking about this video is geometric sequences and series. The last video we were talking about arithmetic sequence and series, which is where we're adding, there's a common difference. Geometric sequence is where we have a common ratio, so we're multiplying every time. So our strict definition for it is going to be a sequence in which each term after the first term is obtained by multiplying the preceding term by a fixed non-zero constant, which means by the same number. So a geometric sequence is where we're going to be multiplying every time. So the arithmetic sequence we're adding every time, geometric sequence we're multiplying every time. So the fixed constant in the definition is called the common ratio. So in the arithmetic sequence we had a common difference we added every time. Geometric sequence we have a common ratio we're multiplying every time. So just a simple version of these definitions. Arithmetic sequence, we're adding or subtracting if the common difference is negative. So if it's changing by a constant amount every time, that means it behaves sort of like a linear function. Geometric sequence, we're multiplying or we're dividing if it's a fraction by that common ratio every time. So we multiply by the same number every time. That means it's going to behave similar to an exponential function. So example of what a geometric sequence would look like. So we have a few examples. So if we had 1, 5, 25, 125, 625. That'd be an example of a geometric sequence. Every term after the first term we multiply by 5, so the common ratio is 5. Like another one, if we had 1, 1/2, 1/4, 1/8, 1/16, 1/32. Same thing, we're multiplying every time. What we're multiplying by each time, that's our common ratio. And on this one, the common ratio is 1/2. Remember, the fact that we get every term by multiplying the previous term by the same number is what makes it a geometric sequence. And we can also, on our common ratio, have negatives. So a sequence like 6, negative 12, positive 24, negative 48, positive 96. That'd be a geometric sequence also. The only difference with this one, we see the alternating negative signs. Our common ratio is negative. Our common ratio here is negative 2. So here's an example of working with a geometric sequence. We're going to write the first 4 terms of the geometric sequence that has first term 6 and common ratio 1/3. So our first term we already know is 6, and then every term after that we get by multiplying the previous term by 1/3. So for the second term, I'll multiply 6 by 1/3, which makes 6/3, or 2. Third term, I'm going to take that 2, multiply by 1/3, which will make 2/3. And for the fourth term, I'm going to take that 2/3 and multiply again by 1/3. That's going to make 2/9. So there's our first 4 terms. So every time we go from one term to the next, we're multiplying by 1/3. That's what makes it a geometric sequence. So just like with the arithmetic sequence, we have a formula for finding the general term or the nth term of a geometric sequence if we know the first term and the common ratio. So to find the nth term, we're going to start with the first term, and we're multiplying by the common ratio n minus 1 times. Right, so that's what makes an exponent. We're multiplying by the same number n minus 1 times, that becomes an exponent. So it's the first term times the common ratio raised to the n minus 1 power. So go through an example here at the bottom. Want to find the 8th term of a geometric sequence that has first term negative 4, common ratio negative 2. So we do for that is use the formula. 8th term would be our first term negative 4 times our common ratio negative 2 raised to the n minus 1 power. So this can be negative 4 times negative 2 to the 7th. So that's negative 4 times negative 128. That will make it positive 512. So we also, just like with the arithmetic sequence, have a formula for the first in terms of a geometric sequence. It's actually finding the sum of those terms. So to find the sum for the first in terms, we have this formula. A1, that's the first term, times 1 minus r to the n over 1 minus r. And the common ratio can't be 1, because that would make the denominator 0. That's just one thing to be aware of. So in an example, we're going to find the sum of the first 18 terms of this sequence. 2, -8, 32, -128. So I can see my first term is 2, and every time I go to the next term, we're multiplying by -4. 2 times -4 is -8. -8 times -4 makes 32. 32 times -4 makes -128. So the pattern keeps going on the same. So I know n is 18. My first term is 2. Common ratio -4. That's everything I need to plug into the formula. So sum of the first 18 terms is going to be 2 times 1 minus -4 to the 18th over 1 minus -4. So simplifying here a little bit, we can do 2, 1 minus 4 to the 18th. So -4 to the 18th will be the same as +4 to the 18th. So you can take out that extra negative, and 1 minus -4 would be 5. So this one, you're going to put this in on the calculator. What the calculator will say is -2.748, and then it will say E10. What that means is -2.748 times 10 to the 10th power. So it's a very large number, so it's more compact to write it this way. To write it out, what we have to do is take the decimal point and move it 10 times. So our final answer written all the way out be this is writing out everything that the calculator gives you, and we're at -27 billion and change. So very big number, so it's easier to write out using the scientific notation. We're just going over, because with these factorials and the different sequences and series, you will get back some really big numbers, so it'll be helpful to know how to go from one form to the other. And then last one, we're just going to do one example of using summation notation to find the sum for a geometric sequence. If we recognize the pattern, we can tell that it's geometric. We can use a formula right away without having to write every term out. So we're taking the sum I equals 1 to 10 of 6 times 2 to the I. So you recognize here that this is in the form of a times r to the n. So it's in the form of a geometric sequence. At 10 up top tells you n, so how many terms you're adding up. So we're going to find the sum of the first 10 terms. And number at the bottom tells you where you're starting. So to find the first term, I have to take this 1 and plug it in for I right here. So my first term would be 6 times 2 to the first. 6 times 2. First term will be 12. And the common ratio is going to be 2. Everything else will be just like on the last page. We're going to use the formula for the sum of geometric sequence. So we start with the first term, 12, times 1 minus common ratio, which is 2, to the n power, so that's 2 to the 10th, over 1 minus common ratio, 2. So keep simplifying, it's going to be 12 times 1 minus 1024 over negative 1. Keep simplifying, it's going to be 12 times negative 1023 over negative 1. Here, negatives will cancel out, so we're multiplying, so we'll just have 12 times 1023, and that gives us our final answer of 12,267. A lot of this is just being able to use the formulas, understand what part of the formula corresponds to what you see in each problem, be able to plug it in and evaluate. If you want to see any other videos, you get some more resources using the same stuff from this video. Search for geometric sequence and series.